to now start another topic. Okay, that is introduction to statistics. The good thing, I had given you summary to almost everything. Okay, in what that is during our introduction. Okay, when I was explaining about the course content of this class. Okay, so let's go to statistics. Of course, you know statistics is a branch of what? Of mathematics. And for my case, I usually say that statistics and data analysis or analytics have no difference in terms of even definition, because data analytics is statistics. Okay, it's like you are using statistics to make what? To like to get information out of data or out of numbers. Okay, so statistics basically, of course, it's a branch of mathematics. And what does it deal with? It deals with collection. Okay, it deals with analysis, it deals with interpretation, it deals with presentation. Okay, and you can see all these are the steps for what? For data analysis. Just to give you some that is a bonus. Okay, when it comes to what? Data analysis. Okay, we know the first step is always to do what? Collect data. You can either that is mine the data, okay, from different websites, or you can that is collect the data direct from the field. Okay, meaning we are talking about secondary source and primary source. Okay, the second step of after that is collecting data, it's what we call now like the data process pre-processing stage. Okay, data pre-processing pre-processing, meaning basically here what you are doing, you are performing a technique which is called DQA. So DQA meaning it's data quality assessment. You are doing what we call data quality assessment. Why? Because before you do analysis, you'd want to have complete data. Okay, so in this case, you'll check on data completeness dimension. Okay, like do we have missing values? How are we going to treat the missing values? Are we going to drop the missing values, or are we going to what? To fill in the missing values using different techniques. You also have to check the relevancy of the data. Like the data which you have, okay, will it satisfy your objective? Because before you do analysis, there is an objective. Like for example, if maybe you are selling a product online, okay, and of late you are experiencing what we call customer churn, meaning most of your customers, okay, are running away from what? From your products. Okay, maybe you will have to get what? Data relevant to what? Maybe to the purchases. Okay, purchasing that is information of what? Of your customers. Okay, then with that you will also go to the rating of that product. Okay, so that you may know what we call, that is the RCA, the root cause analysis. Okay, to see what is the problem. Okay, or why are my customers, okay, not buying my products. Okay, so you will need data which is relevant to what, to your objective. So like you can't now that is use, maybe you cannot use stocks data here, okay, to analyze customer churn. So there must be relevance, okay. So after that we have around 8 dimensions under data quality assessment. You are trying to clean your data. Data pre-processing, it's like you are investigating your data. Is your data that is a quality data for you to use to do analysis, okay. If you find maybe some that is problems like blanks, like missing data, okay, what are you going to do? Maybe in your data you might be having some irrelevant information, okay. What are you going to do with those columns? So we have around 8 dimensions under here: completeness, relevancy. We also have what we call that is, there is this word which is I'm not can't remember it, but we have like 8 dimensions, okay. All right. So that is the always the second part of data analysis. You are doing what? You are cleaning your data, and it is in this stage where you can take what, where you can take even a day, depending on your data set size. You can spend hours or a day or days doing data cleaning. Basically, this is the stage which takes time when it comes to data analysis, because you have to check some, if we have dates, do we are all the dates, are they in the same format? Like we have very like very or that is a lot of work, that is in this stage. Then after that, now you'll come to the data analysis itself. Data analysis itself. Now here you are doing analysis, you are trying to find some insights, okay, out of what, from your clean data. Then the fourth stage, it's always the interpretation, okay. Like after now doing the data analysis, what values, or the values which you got, what does they mean, okay. What does maybe that is a variance of 0 point or a variance of 90 mean? What is correlation of 0.85 mean? Okay, so it is all under what, interpretation, okay, in order to do conclusion. So interpretation and conclusions work together. And then the fifth stage is always now the presentation. How are you going to present your data? Of course you will use graphs, okay, because of course your boss, if maybe you are working in a company, your boss will be interested to see the visuals or the data visualization. In fact, this is the data visualization and presentation, okay. Visuals, which visuals are you using? So even if you are using coding to do your analysis, okay, your boss won't be interested on those codes, okay. Those are your areas of expertise. Your boss will only need maybe to see the graphs, to see how maybe in terms of sales, how our sales or our sales have been trending, okay. Are we moving to upward trajectory, or we are moving on a downward trajectory, okay. So that he might now do some conclusions, okay. Then of course presentation, you might use PowerPoint to present your data, and even more, there are very many tools which can be used for do what, for data presentation. Okay, all right, this was just a bonus. Anyways, we are talking about statistics. You can see we've covered all these stages. Okay, data collection, analysis itself, interpretation, presentation. Okay, so that's the definition of statistics. It's also a definition of data analytics. So that types of statistics, we said we have theoretical statistics and we have applied statistics. For theoretical statistics, it's more of theorems, different theorems in statistics, and we are not going to focus on that because it is a lot. It is a lot. So for our case and also for our knowledge, because of data science, we'll go with what? Applied statistics. I said under applied statistics, we have descriptive statistics and inferential statistics. Okay. And of course, we'll start with descriptive statistics, and then inferential statistics will take it later when we'll be discussing about distributions and also uh, hypothesis testing. Okay, all right. Let's start with descriptive statistics. From the term describe, it's like we are trying to get an overview or a general summary, okay, of what? Of our data sets. Okay. So like for example, under descriptive statistics, we usually have what? We usually have different measures, okay, and we shall check into those measures one by one. Okay. So like for example, under descriptive statistics. Someone who has a question? Yes, Titus Mwanza, you can see your hand is up. Question? Okay, sorry, he has left. Okay, so under descriptive statistics, let's assume we have two data sets. Okay, we have rainfall amount data. This is rainfall amount in millimeters. Okay, and we have umbrella cells. Remember, umbrella cells depends on what? Rainfall amount. Like it's seasonal. It's a seasonal kind of data. Yes, Titus?
Okay, so sorry for interrupting.
Okay,
Yes, I have a question
all right.
before we proceed. Do you have any tools that maybe can help someone clean the data when you are doing data cleaning?
So maybe unfortunately, I don't know if we have, but unfortunately, as per my knowledge, we don't have that is a tool which can clean data. Why? Because now that's where you come in. Okay, that's where you come in. Like for example, if maybe let's assume we are using Excel. Okay, or maybe you are using Python. Of course, you have to code. Okay, to remove columns which you don't have. Okay, to check columns which have missing values, because if we were to use maybe a system, okay, then out of maybe a data set with 1,000 entries, you might find yourself working with what? With a data set of 20 entries. Okay, so for that is for data that is cleaning. That's where now we need that is a human intuitions and also human judgment. Okay, so unfortunately, unless maybe someone is aware of a tool which can clean data, but for those years which I've worked as a data analyst, okay, I've never came across that that is such tool, unless maybe we have some people who are working in tech companies. But what I know, for data analyst or data scientist, that's where you come in, cleaning and analyzing the data. I don't know if Titus, okay, you are okay. All right. Good. We are discussing about maybe remember, like the umbrella cells depend with what? With amount of rainfall. We know that this is kind of data which is affected by season. It's a seasonality data. Okay. Like for example, whenever we have high rainfall amount, it's when we usually have high sales of umbrellas. Okay. Even if at times when it's a sunny period, okay, some people tend to buy umbrellas, but it's very hard, okay, in that case. So but it's normal that when during the rainy season people will buy more umbrellas, okay. All right, so in this case, definitely if it is rainfall, this will take continuous data, and this will take what? Discrete data. Okay, we can have 8.32 millimeters of rainfall, but we cannot have two and a third umbrellas. Okay, so in this case, um, let's assume you are given that is a data set. I guess I have a data set, umbrella cells. Okay, let's assume it's this data set. Okay, we can do a summary statistics, or we can do a descriptive statistics, okay, which will give us a summary of what? Of this data. Okay, maybe I'll just do it quickly so that you may see what kind of summary I'm talking about. Okay, don't worry about the process which I'm using, because I will also take you through this during our practicals. Okay, so maybe I can take from the rainfall amount. I just want to see to do a summary of my data. Okay, so you can see I have done a descriptive like summary or a descriptive analysis of what? Of this data. Why? Because I know averagely we have average, that is the average amount of rainfall in these 2 years. You can see this is 2016, 2017. We have an average amount of rainfall of 114.15 millimeters of rainfall. Okay, we have a median, or the median of the that is of the rainfall amount is this. We have a standard deviation, okay, of this. We have a sample variance for rainfall is this. We have skewness, we have range, we have a minimum value, we have maximum value, we have the sum, and we have the count. Okay, when we come to umbrella cells, the same thing. So basically you can see I have a what? Descriptive statistics. And we've said descriptive statistics basically describes about what? About the data. Okay, don't worry about that. So let's try and see what descriptive statistics is. So for descriptive statistics, um, is a term given to analysis of data that helps you or helps us to describe. It only helps us to describe or show and summarize data in a meaningful way. It is a way, or it is a simple way to describe our data. Descriptive statistics is very important to present our raw data in effective and meaningful way using numerical calculations or graphs or tables. This type of statistics is applied to already known data. Of course, for descriptive statistics, you must have the data available. Okay? You must have the data available. And we have different types of what? Different types of descriptive statistics. We have measures of central tendency, we have measures of variability, and also we have measures of asymmetry. But measures of asymmetry, we'll learn more about them under that is under distributions. Okay? All right. Good. Any question up to that point? If we are flowing well, if we are all together, maybe you can just show me through a thumbs up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I can see at least a sample of 13 people. Okay. Yes, Elizabeth?
Will we go deep into the from that descriptive analysis? Will we go deep into the kurtosis, the skewness,
Of course, but
on how?
that will
Okay.
do under distribution. We shall see what is kurtosis. When we talk about kurtosis, okay, like the thinness and the thickness of the tail, how can we compare normal distribution, different normal distribution? Okay, kurtosis. So with that we shall, but we will generally talk about it and maybe calculate it. Okay, but will not mathematically calculate it. Will not do like mathematically calculate it. Okay, but I will explain what kurtosis is in case you get a kurtosis of 3 or less than 3 or more than 3, what basically it means. Okay, yes, but kurtosis is the fourth moment, okay, from the mean, and skewness is the third moment from the mean. Okay, as variance is the second moment from the mean. But for that, I won't go into details on that. But at your free time, you can always what? You can always go through that. I hope we are together. I'll give you everything, but whichever it's within the scope of the class. And then I will also advise where you can go further and learn about. Okay, we have mean, mode, and median. Okay, so I can see time as we are almost 8 minutes to time. So basically, I want now just to do an overview of all this. Okay, and then now tomorrow we can discuss each that is each one. Okay, when we discuss about mean, what is mean, mode, median. Okay, but basically right now I would just want to make the class more interactive, so I will ask, like, what do you understand by the term mean? Okay, what do you understand by the term mean for the next 7 minutes? Yes, Rebecca.
Mean is center,
Center.
average. Mm.
What about median?
Okay, mean is average of
Yes,
something.
correct. So mean is the symbol average. Okay, mean is the symbol average. Let's assume we have like weight of 5 students here. Okay, we have 30, we have 50, maybe point zero. Let me just do 50.0. We have 45.0. We have 51.25. Okay. No, let me just use one decimal for easy calculations. 0.5, and then maybe we have 70.1. Okay, 0.5. So basically, what we are talking when we are talking about mean, we know that of course we have population mean, and we have sample mean. Sample mean denoted by x bar. Okay. Population mean denoted by mu. Okay, so let's assume you have five variables. Let's say the five values of weight, that is x1, x2, x3, x4, and x5. Okay, then we know that mean is the sum of all values divided by the count of values. Okay, so the count we can say n, where we usually term n as the sample size. We usually term n as the sample size. So in this case, we can see n is the total count of each value. Okay, so in this case, our mean or our sample mean, that is x bar, will be x1 plus x2 plus x3 plus sorry, x4 plus x5. Okay, and you can see we have how many i's. Remember, this is xi's. Xi's meaning it's taking a value 1, 2, 3 up to 5. So our n is what? 1, 2, 3, 4, 5. So our n is 5. So basically this is what? This is the sample mean. So in this case, for us to get mean, is you take this value plus this value plus this value plus this value plus this value, divide by the what? The total count, which is 1, 2, 3, 4, 5. Okay, so you had this divide by 5. Basically, that's what we call mean. Mean, by definition, it's the simple average. Okay, all right. What about mode? Yes, Genvia.
Yes, sir. I would like to ask you if the sample mean,
Mm-hmm.
the normal mean, I mean, the mean of the whole population and the
Uh-huh.
mean of a certain sample out of that population, are they calculated in the same way?
Um, for the mean, that is of the population and the
Mean of the sample out
yes.
taken out of
Yes,
that
for
population.
yes, you take all the population, or you take all that is the data for all population, then you divide by the that is the n, the capital N, or you divide by the what? By the total count of the population. But for variance and standard deviation will be different in terms of formula. Okay, I shall explain that when it comes to variance and standard deviation. But that's the way we are calculating sample mean, the way we can calculate the population mean. Okay.
Because I asked this question because maybe I
Mm-hmm,
don't know if I'm mistaken.
mm-hmm.
Uh, Maybe I saw somewhere they say maybe the total of the values over the count of the values minus one.
Yes. So yeah. But when we
Does something
minus,
like that exist?
yes, I know. Like for example, if I take the total of xi's, divide by n minus what? Minus 1. Okay, what will be this? Will this be population or will it be sample? question, like if I had all the xi's, summation of all xi's divide by n minus 1. You know this n is for what? It's for the population, but we've minused 1. What is this? Will this be sample or will be population? Jaimva?
I think it's the sample one.
Correct. It's the sample. Why? Because we've not reached the total count for population. We know the total count for population is n, but we are less 1 in this calculation. So basically this will be sample. Okay. So for sample it can also be like n minus what? N minus 1. Okay. We have different methods of calculating that. All right. I don't know
So
if
so that means
uh-huh, uh-huh.
so that means you would like to say that the way of calculating the sample is not fixed. We can either say the sum of the values over the count of the values, or the sum of the values over the count of the values minus one. Either
Yes.
of
Either
the two
of that,
would
it will
be
calculate
would be
sample.
the mean of the sample.
Yes, correct. Why? Because in this case, we've not reached the what? The total count of the population. You can go and check on that, okay? And then we can maybe discuss further. Just go check on that. Come with evidence. Let's discuss. But that's what I know. N minus 1, meaning we are less than the population. We are less something than population. It can be less 1. If we less 1, it won't be a population. It will be a sample. Okay. That's why you will see, you will come to see when we are dealing with that is the variance. Okay. That is for the sample, we usually use n minus what? N minus 1 when it comes to what? It comes to variance. You'll see that. Okay. But for population, we are only using 1n, like, and it should be capital 1n. Okay, Jenva?
Okay, yeah, we can continue. I'm just researching about it.
Yes, you can go and research on it. And then you can now bring your findings. We discuss. We agree, we disagree. Of course, that's the work of statisticians. You have to prove. Okay. All right. Let's go to mod. What is mod? Let's keep it quick.
Mod is the number that appears most in a sample for example.
Okay, that's okay. So, mod, it's a number that is the most occurring value. Okay, that is for single mod. Okay, we might have different mods. Okay, which is multiple mod. Like for example, if I say 1, 3, 2, 1, 5. What is our mod here?
No,
What is our mod here?
I think
One.
mod
It is 1.
is the character or the number that is appearing most.
Yes, that is 1. That is 1 is appearing twice. Okay. What about when we are talking about that is 1, 3, 1. We have 2. We have 5. We have 2. What is our mod here? We have here, we can express as well 1 mod, and we can express 2 mods. So for one mod, it's single, and for multiple mod, it will be like two values. So tell me, which is single mod from this, and which is the multiple mods from this? No, it's confusing, but there is a point I want to drive home. So if we are talking about single mod here, the first value, okay, which will be like occurring more than once, it is the mod. Like in this case, our single mod can be 1. Why? It is the first one to occur twice. Okay. Then when we talk about multiple mod, okay, when we are talking about multiple mod here, then it will be 1 and 2. Why? Because 2 is also occurring 2 times. Okay, so in case maybe you have this value and you are told to run a single mod, then the first occurring value, okay, like the first 2 occurring value, then it will be what? It will be your mod. In case you are asked about multiple mod, then the 2 values. Your mic is off. Oh, sorry, guys. Sorry, guys. Sorry for that. Let me repeat. Can see someone had texted me. My mic is off. Okay. All right. So, when I was explaining this, in case maybe you are given this kind of data, and they asked you, we need a single mod, then the first value which occurring more than once becomes your single what mod. So in this case it will be 1, even though 2 is occurring more than once, but it's in the second, like it is not the first value to occur more than once. Okay, then if you are asked about multiple mod, okay, then it will be what? 1 and 2. We shall see that in our what? In our example. Okay, we shall see that in our example. Is that clear? Is that clear? I can see only 2 people. Rebecca, I can see thumbs down. Okay, good. Now let's go to the last one, median. What is median? I will stop under medium, so that now tomorrow we may discuss this and then come to measures of variability. What is median? Someone?
I think median is the one that appears in the middle of the data.
Okay, that's your point. But at some point I disagree. You have omitted something. Someone else?
When you arrange the data, maybe in an ascending or descending order, then
Yes.
whatever comes in the middle
Yes, that's now
becomes a
correct.
median.
Yeah. Yeah, that's now correct. So when we talk about median, we are talking about that is the middle, all the central value in an ordered or sorted, that let's say in a sorted list, okay, or in a sorted that is, yes, list of values. Okay, so you can either sort it in a ascending order or descending order. Okay, and tomorrow we shall see like how can we get maybe the median when we are given set, that is set of odd in terms of count values. Like for example, if I say 1, 2, 3, 4, and 5, what is the what is the median? Definitely it's 3. We've already sorted this data. Okay, it is 3. What if we had 6? What will be our median? So you can see in this case we have two middle values. How do we calculate the median out of these two values? So we shall see the median when we are given the when we are discussing about okay, given two different scenario, when we have odd count of number and even count of number. Okay, all right. Okay, any question before I can end my today's class? Sorry, I've